Hello, my name is Carlos and I'm from Portugal. I work for Linkit for almost 3 years now, and I have 6 years and a half experience in OutSystems, and I already worked for several clients in the Netherlands. Okay, so today we are going to talk about quality assurance. First, we need to understand what is quality assurance in IT. Quality assurance is the process to give management the confidence that an organization will deliver quality information technology, product, and services. The ultimate goal of any business application is to produce accurate results and provide an enjoyable and pleasurable experience. And so performance is key to an application. In OutSystems, quality assurance can be met by the technical knowledge of the developers, but also by following some of the OutSystems best practices. In OutSystems, we have lots of best practices. We can have OutSystems platform best practices, we can have mobile best practices, we can have front-end architecture best practices, and we can even have reactive web security best practices. Today, we are going to focus more on the OutSystems platform best practices, mainly on the performance. As I already mentioned, today we are going to focus on the performance best practices, but we have lots of them and they are divided into categories. And so we can have best practices for naming and coding conventions, best practices for CSS, HTML, JavaScript, security, architecture, and so on. The first best practice that I want to talk about is the indexes. Creating indexes will improve greatly the performance of your application. But first, let's try to understand what is an index. So essentially, an index is a data structure that improves faster access to the database. It's a copy of the indexed column of the table, and it can quickly locate without having to search every row in that table. Why? Because it includes a key or a direct link to the row. So we can have unique and non-unique indexes, and the OutSystems platform will create automatically indexes for the primary keys and for the foreign keys. Okay, so when it comes to non-unique indexes, it's really up to the developer to try to find what are the most commonly used attributes in where clauses and join expressions. So we should create a non-unique index composed by only one attribute for the OR clauses, and for the AND clauses we should create a composite non-unique index that will be composed by several attributes. For indexes, column orders are important, and so it's really important to try to build your composite indexes where the attributes are going to have the same order as they are being used in your queries. Okay, we talked about the non-unique indexes, but we also can create unique indexes. We should create unique indexes when we want to prevent a duplicated combination in the database. We shouldn't do any server-side validation to check if the database already has that combination. And so the idea is really to create a unique index that on insert, if there is a duplicated combination, it will throw a database exception, and then you can just grab that database exception and send a friendly feedback message to the user. One other best practice that we should follow is to isolate binary data and large text fields in a separate entity. If we have a binary attribute in a table that is constantly changing, updating that binary is going to be really slow, because usually binaries are relatively large, and also because data pages need to be moved for the binary type. We should do the same for large text attributes with a length that is greater than 2000 characters, because they will also be mapped to binary data types in the database. One other best practice is to simplify screen preparations. The preparation is a server-side action that will run synchronously, meaning that only after all the elements are executed in the preparation, the page will start to render. And so it's really important to have really simple preparations. And so when it comes to the preparation, we should try to avoid to have database write operations, to have cycles in the preparation, and also complex validations. One other best practice is to use advanced SQL for bulk operations instead of doing a cycle using entity actions. We should try to write queries that will insert, update, or delete as much data as possible. Why? Because every operation done against the database is going to pay a round trip communicating with the server. And so the sum of all these round trips can hinder the performance of an application. One other thing that we should really avoid is to have a query inside a for each. By having a query inside a for each, we would have to go to the database for each record. And so it's always preferable to create a more advanced query, maybe with a subselect, in order to avoid that aggregate in the cycle. And so if we have a query inside a cycle, in each record we are having a round trip to the database. The query results will be loaded into memory, and this will increase memory consumption.
Let's see this example. So in here we have an entity of weeks, and the weeks can be blocked. So let's imagine that we want to block all weeks. Instead of doing these in a cycle for each record of weeks, setting the isBlocked attribute to true and then updating the corresponding record. If we have lots of records in the week entity, this can be very time consuming. And so the idea is really to do this in a bulk fashion. And so these can be translated to these. These will be much performant and fast. Let's see another example where we can gain performance by doing bulk operations. So in here, I have an action that will iterate the weeks, and then it will update the week, setting the cost center for the week based on the cost center of the correction table. So for each record, we are making a query where we are saying that we want the week or the correction where the year is equal to the year of the weeks and the week of the correction is equal to the week of the week. And by each record, we are setting the cost center that comes from the correction. These can be transformed into an advanced query that will do the same, but instead of iterating and going to the database in each record, we'll do this in a bulk fashion. Let's see another example where advanced SQL can help us to reduce cycles in the application. We have this application right here where we can create correction range and corrections, and we have this save screen action. This save screen action does some form validations, and then based on the start and end date will give us the corresponding week number and year. And after that, we will assign to these local variables the result from these actions right here. And then in this aggregate, we use the result of the local variables. And basically, if the aggregate is not empty, we want to create a correction range and also the corresponding corrections. This can be done in a cycle, but if we have lots of records to create of corrections, this means that we are going to have a performance hit in the application. And so this can be replaced by an advanced query by doing an insert from select. So in here, I have the same flow, but without the cycle. We have the same form validations, we are using the same actions. If the query is not empty, we want to create the correction range, and then we want to create the correction. So this cycle can be replaced by this advanced query. So essentially what we want is to do an insert from select. In this case, we want to do an insert into correction based on the selection that we do for the weak entity. This will make the application more performant.
One other best practice is only to get the amount of rows that we want to display in the screen. And so we should set the max records property of aggregates and advanced queries, because this will optimize the query execution time and also the screen rendering.
Let's see an example where not setting the max records property on a query can have a performance hit in an application. So we have a screen where we can create corrections. So we have this button that will trigger the opening of the modal. The modal has a start date and the end date, and essentially it's populated based on the last record and the last date range of the last record. If we go here, we have this preparation and we have two aggregates, one for the modal and the other for the table records. By not setting the max records property in this query, we can have an impact in the performance. Let's try to see how many records we have in here. We can do a count to check how many records we have in the database. As you can see, these are a lot of records. We have 250,000 records, meaning that by not setting the max records property of this query, on the preparation, we are fetching 250,000 records where we only want the last one. So remove the count, setting the max records to 1 will do the trick, and we are just going to fetch the last record.
One other best practice is really to minimize the number of executed queries. And so it's really preferable to build a more complex query than having lots of simple queries, because that will also be a round trip to the database. Okay, now let's talk about some best practices that you should really execute in order to minimize the view state of a page. But first, let's try to understand what is the view state. The view state is a hidden portion of the rendered web page where screen input parameters and local variables are stored. The OutSystems platform includes some of these screen parameters and local variables in the view state because it needs to know the state of them and preserve the value of the page between round trips. We need to pay attention to not create a great amount of data, because that will increase the view state, it will degrade the performance of the page, and even can cause runtime errors because of the limitation of the objects that you can have in a page. Traditional web applications have a view state, but you don't need to worry about the view state when you are building mobile or reactive web applications. Okay, so the first aspect that I want to talk about regarding the view state is that we should try to minimize the screen input parameters and local variables, since they are stored in the view state. And so we should try to have entity identifiers or light data types in the view state, so it's lighter and will not have an impact in the performance and also in memory. We should avoid at all costs to have screen record input parameters or screen list input parameters, because those data types are heavy and these will have a huge performance hit in the page. One other thing that we should do is never to use the preparation data in screen actions, because that data will also be stored in the view state. If you do this, the page size will increase, and that will affect the user experience because it will increase the loading time of the page. Most of the time, it's just better to do a second query passing just the needed identifier. One other thing that we should really avoid is to have binary loading in the preparation, since binaries are usually large attributes, and because of that it will make the query really slow and also the screen rendering really slow. For instance, if you have a screen where you want to download a CV, and if the download action is a screen action, you shouldn't have to put the binary in the preparation because it's not needed for the rendering of the page. We shouldn't also use conditional queries in the preparation because that will also increase the page view state. If a query is only executed in a if branch in the preparation and then used in a table records, all of the data needs to be in the view state. Now I would like to talk about the three different methods that you have in traditional web applications in which inputs can be submitted. As you know, we have the navigate method, we have the submit method, and we also have the AJAX submit method. Although this is not part of the best practices, not understanding the difference of these methods can have a huge impact in terms of performance. Bear in mind that doing a navigate to the current screen, doing a submit ending with the end node, or doing a submit as destination to the current screen will rerun the preparation. If we have huge and complex preparations, this will have a performance hit in the application. The same does not happen with AJAX submit, since AJAX is asynchronous and it will run in the background, and so the page does not need to be rebuilt once again every time the user has an interaction with the page. The only thing that will happen is that some of the UI elements will be refreshed.
Okay, so now I would like to share some metrics with you about a refactoring project that I was involved in. This project was for a German client. The application was already in production and they had several issues. The first issue was the fact that they didn't have any index in the application. The application was really slow, and after the refactoring, we introduced 19 non-unique indexes, making the searches in the application much faster. The other metric that I want to explain is that they also didn't have any unique index. So they were doing server-side validations to check if a duplicated combination already existed in the database, and this is not needed. And so because of that, we created 5 unique indexes. Um, Regarding screen parameters, they had 73, and we were able to reduce the screen parameters to 12. This means that the view state is much smaller and that the page size is also much smaller. Screen local variables, they had 221, and then after the refactoring, they had 38. This also has to do with the view state. So the idea is really to reduce the number of screen input parameters and screen local variables to a minimum, so it doesn't affect the view state and the page size. Um, we were able to reduce a lot the number of cycles because we did more bulk operations. So before the refactoring, they had 173, and after the refactoring, they only had 4 cycles. List append, because they were using a lot of cycles, they also had lots of list appends. So they had 227. After the refactoring, they started to have 5. Advanced queries, they didn't have any advanced query because they were not doing any bulk operation. They were using a lot of cycles. Because we were able to reduce the number of cycles and because we did much more bulk operations, we were able to increase the advanced queries from 0 to 51. The number of aggregates were reduced, and this has to do with the fact that we were able to do less aggregates, but more powerful aggregates with more joint conditions and entities than simple aggregates as they had in the application. Um, I also mentioned that if you don't choose the right methods, this will also be a performance hit in the application. They were doing lots of navigates to the current screen and also submits ending with the end node and as destination to the current screen, which makes the preparation rerun again. And after the refactoring, we used much more Ajax submit, and because of that, we were able to increase the number of Ajax refreshes from 48 to 161. Same goes for the refresh queries. Because we are using Ajax submit, we were able to increase the number of refresh queries that the application was using. They also had some UI duplication, so they had some reporting screens where the UI was similar and they were not using weblogs, and we created weblogs so these UI parts can be reused across the application. Same goes for code duplication. They also had some code duplication, and we identified those areas, and we created user actions to be shared across the application. And yeah, finally, they had 38 warnings, and after the refactoring, they didn't have any warnings. And as you can see, yeah, quality assurance in IT is really about this, is about following the best practices. And as you can see by the metrics, we were able to really increase the quality of the application.